the Project 8 introducing the resistor. In the previous experiment, Light Telegraph, I showed you at least how to turn on the LED with the resistor. Also, the resistor is also good for LEDs because you don't use too much electricity for LEDs because of how small they are. They shouldn't be using so much of that voltage from batteries, or like there's not much volts from batteries, but a small light like this shouldn't be using that much electricity. So that's why we have resistors. Now, in this project, we have now two resistors, now as you can see. Both of them being 470 ohms, as explained from last time about the rings. They are exactly the same and identical to each other, just installed in other places now. As you can see, these wires are connected from one side to the other. The resistor here is being used to transport resisted electricity to the minus, or I'm sorry, the negative terminal does not have a part where it's connected to the switch that I have operating now, which I'll zoom out in a little bit. But this resistor is basically now just like a resisted wire, which is now controlling the electricity, which is why the LED is constantly on for this project. Now, turning on the circuit, if you can see in the top left corner, something is going on with the LED. It's flickering. Now, what the idea is about the project is that it's showing you about that resistance. If you resist more electricity to your circuit, less electricity is being eaten up from the resistors and causing the LED to dim as you have more resistance. I don't know how to communicate that professionally, LOL. But as you know, when I turn on the switch, now 470 times 2 is, I believe, 940 ohms. So basically, instead of 470 ohms, we are now using 940 ohms. So basically, more of that resistance is eating the electricity, which means there's a lot less electricity flowing to complete the circuit. Basically, if you were to look at a schematic, in which I'll show you now, the battery starts here at V6. What I'm using, by the way. A wire's connected there, which is 9 volts. What's going on is, let's see here. The LED is already connected to the circuit because there's no switch. Now, the switch here is that a 470 ohm resistor is parallel to the circuit. So even if one resistor goes down, even if one resistor is turned off, the LED remains on. And the LED remains brighter in the circuit because there's no switch. Now, turning on now, basically you have, when the switch is turned off, which I believe is right here from 48 to 49 in the schematic, you still have 470 ohms going, you still have a completed circuit. So basically what's going on is the circuit is still closed and there's only 470 ohms, which means there's still going to be a lot more electricity to be used for the LED. So the LED is brighter. Now, if the switch was turned on, we would now be using 940 ohms as mentioned. Parallel here within this square, the current from not going this way, but now going this way within the schematic, you are now using the other resistor, which is now making more resistance. So the LED being here, flowing through the circuit, would be much dim. Well, not very dim, because 470 ohms is kind of low to help with the brightness change of the LED. And here's the schematic down up here at Project 8 introducing the resistor. Basically, since the metal little things are in rows within these holes that you can see, these wires here are connected to the switch indicated in numbers. The resistors here are completing the circuit of the battery. The positive terminal is right here within V6, which indicates that it's 9 volts, using up 9 volts. Which basically, the reason why they're like this is because there's 6 AA batteries. As you know, these kind of act like the little batteries. But the batteries are not exactly in here, they're somewhere else. Up here, this is where, from here to here, within a diagram or schematic standpoint, connections 1 and 2 are the LED. So that's basically connections to the LED. I hope this is helping you guys. I hope this is kind of helpful. I hope I'm at least explaining a few things that might be kind of cool. I mean, I know that I'm a car washer and I will be doing fire alarms soon, but I also have these and I think they're kind of cool and I would like to show them off. Maybe almost all the experiments from all of them, maybe. But yeah, so hope you guys enjoyed. Thanks for watching. See you guys in the next video and peace out, everybody.